Hello, everyone, and welcome to another episode of Simplified Network Automation with NetGrew. We have Story DeWeese back on the stream. Welcome back, Story. It's great to see you. How have you been?
Yeah, thanks for having me. Been great. Yeah, doing well over here. Lots of stuff related to programmability and automation, so I'm always staying busy.
I know you and Jeremy, you folks are super active, working on a lot of content. What else we have coming up? We have coming up the sandboxes with the Catalyst hardware. We've been talking about them for a bit now, but they're finally getting almost ready to go production. I know we've all tested the sandboxes in the back end. So excited about that. Yang Suite, right? We've talked about the Learning Lab over there also at Cisco Live. But for today, we're going to talk about Secure ZTP, right? So tell us a bit about how did you get to develop this content? First of all, I mean, I know there's interest from people, but what made you get this topic and where are you at with it?
Yeah, definitely. So on iOS XE, we've supported just classic ZTP for a while now. And then more
Mhm.
recently, we introduced Secure ZTP. So really, we're trying to make things more secure in how we're onboarding our XE devices. And yeah, so that's how I got plugged into it. Is like we want to enhance and make more secure features as often as we can.
Gotcha. And for folks that are new to device onboarding, right, ZTP stands for Zero Touch Provisioning, which is a protocol that's been developed for like bringing up these devices. Either if you're like brand new switch, uh, right, you bring it on the network and you want to automate the process of onboarding it, of adding it into your network. That's where ZTP comes in the picture. As the switch boots up, right, by default, ZTP is on. I want to say like the ZTP agent on the switch, right, and it tries to reach out to a DHCP server. But we'll talk about these details in a bit, right? I mean, I know you have some slides, but zero touch
Yeah,
provisioning, right? That's where it comes in, and like you said, iOS XC supports it now for many years with Secure ZTP, and then there's also plug and play. How does that come in the picture?
Yeah, great question. So, plug and play is with our Catalyst Center controller. So, if you want to go ahead and onboard your devices into Catalyst Center, you'll use plug and play. So, similarly, we have ZTP or Secure ZTP, either option. And so, these are controllerless ways that you can onboard your devices. Yeah, so that's the main difference here. If you have Catalyst Center and you want to use that for onboarding, or if you have other approaches as well.
Gotcha. All right, so let's jump in. Show us a bit. I know you have a demo, you have a recording of a demo, which we'll talk about around it. Yeah. Uh, and you have
Yeah,
some
definitely. Can you
slides. Yes, there we go.
Okay, awesome. Yeah, so we'll talk about leveraging Secure ZTP today, and specifically for our Catalyst or our iOS XE devices. Yeah, so I have just a brief agenda here, but I want to start off with a demo and showing how does a Secure ZTP actually work, and then we can break down all the different components. Okay, what's going on at play? What needs to be set up? Maybe ahead of
Hmm.
time, and then get into some resources at the end here. Yeah, so we can go ahead and get started. This is the brief, intro overview of what we'll be chatting about today, but let's just go ahead and get into it. So to start off for our demo, I'm gonna have some configuration that I want to push to our device at, day 0 here. So I want to go ahead and make sure that the device has these specific configurations when it's actually onboarded. So I just want to highlight here one thing that's important is the host name. We're going to see the host name change in the demo coming up. So before, it doesn't really matter what's on the device. It could have been, used a long time ago. Maybe it has an old host name, old config, for example. Or maybe you just got it fresh out of the box, right? It's just been shipped to you. And you plug it into your network, and then it will use DHCP to go ahead and grab these day 0 configs. So either option is like possible, and we can go ahead and get into like the demo of how this actually works now. So I have 3 different screens here, and, just to kind of, like, orient us, the one in the top left over here, this is the device that we're actually going to run the Secure ZTP process on. So you can see it already has some config on it. This is a 9300X box, and we're going to go through and run a write erase reload. So we're basically going to set it back to, its factory settings, its presets over here. And while that's coming back up, we'll look down at the bottom left, and this is another device on our network, and it actually has DHCP configured. So we'll see that from this device, we'll be able to go out and find all of our bootstrapping data that we need because DHCP will point us to that bootstrapping server where we can go find all the scripts and everything that we saw from, the previous slide. We'll find, how to change our host name to get our preferred day zero configs. Then we'll look over here on the third screen, and this is actually the bootstrapping data itself, the bootstrapping server. So we can see all of our different configuration files, including what we were just looking at on like the previous slide here. So let's get into it. First of all, we're going to go to our device and run this write erase. We're going to go ahead and confirm that, saying we want to wipe the box clean, and then we want to reload it. So in this case, we do not want to save the config. We want it to just come back up fresh as if we had just gotten it delivered, for example. So next up, we can go ahead and look at the DHCP server while this is coming back up. So again, this is another device on the network where we have our DHCP configured over here. And you'll notice we have option 143. So this one is required by the RFC for Secure ZTP. We need option 143 within DHCP to follow all of the standards. And that's pointing us over here to our bootstrapping server itself. And we can look at our configuration. Okay, so this is encoded. Let's look at the decoded version of it. And we'll see the same exact scripts and configuration that we saw from the previous slide. So we're going to set our host name over here. Now we can go back to our device and we'll see that it's coming up. We see it found the bootstrapping server list and was able to go there, get all of the configuration needed. And now we have modified, the host name, and this matches what we had in our bootstrapping data. We can also go through and show the DHCP bindings to just kind of validate, okay, yes, a new device has been given a DHCP lease over here. So this is essentially the demo of Secure ZTP and how it works at a high level. So we're going to be using DHCP option 143. We're going to go out, find our day zero configs, and actually load those onto the box. So this is the overall demo for Secure ZTP.
Okay, so then I have a bunch of questions. Option 143. Right, you had like a bunch of garbled hex text. What is that? How do you get to that? Because I would imagine it's pointing the IP address of your bootstrapping server. But what else is in there? Because it was like a long string of hex characters.
Yeah, great question. So you're exactly right. It is pointing us directly to our bootstrapping server. So it's actually an encoded version of how we like point to that bootstrapping server. And we actually have like a full guide on how to get that. So probably you'll start off with something that's like an IP address or IP port that's going to point you in the right direction. And then in the guide, we show you how to change that into your hex code that you need for this particular, DHCP option over here. Yeah, so I can like show the guide, at the end of the session so you can go through and see exactly
Okay.
how to get all of that hex and how to put it in here properly for DHCP.
All right, gotcha. Then, so you got your bootstrapping server on the right. Are you accessing it over HTTPS?
Yeah,
Is
yeah, it's
that
a
where the
secure
secure
connection.
in secure ZTP comes from? Like, that's one component, basically.
Exactly. Yeah, that's one component. There are a lot of other keys and certs and vouchers and stuff that also make it secure, but that's one component. Yeah, HTTPS.
Okay, so then let's see these components. Is that what we were going to cover next?
Yeah,
All right.
exactly. So, okay, break it down. Let's actually get into it. What are
Store, you're cutting off. I don't know if it's only me.
Have our
I can hear you a bit now. Hello?
hello, can you hear me?
Yes.
Nice. Okay, hopefully I'm back. Um,
Yeah.
so let's get into the different components here. So this is the overview, and we have the three same components that we were just looking at in the demo. One is the device itself that we want to onboard. So this is our iOS XE device. One is our DHCP server, which in our demo we were showing this is actually on another switch in our network. And then the last one here is the bootstrapping server. So this is where all of the goods, all the onboarding data is. And this can include things like our day zero configuration, or if we wanted to say like upgrade our device, we would have like the binary files, the images, all that good stuff would also be over here in this like bootstrapping server. So the first step here is we plug in our box to the network, or sorry, we plug in the box over here and it does our DHCP discovery. And this is where it finds the option 143, all the hex code, right? It finds the pointer to our bootstrapping server. So then we can do the TLS handshakes. We'll be using the SUDI certificate for this. And we can do the server, we can get the server certificate back. So then once we do, a few more things, we'll be able to eventually get all of the onboarding data, including those scripts and everything. Those will come from our bootstrapping server over here on Box. Then we can actually load those for our day zero config. So again, a lot of different components, but we can dive deeper into each one of these.
So then how do you get the studio certificate on the device and the private key? Is that like, how do you generate them? It's just like a private public key pair that you generate, and you put your private key on the switch and then the public key on the bootstrapping server?
That's essentially what's happening is we have this public key, private key setup, but the SUDI certificate itself, this is actually burnt onto the device at manufacturing. So you don't need to create
Okay,
anything. It's going to be there already. It already exists once you get the device.
I see. So then that's kind of like a Cisco certificate. What if you have your own certificate or your own SA?
Yeah, good question. So for this like first handshake here, we'll be using the SUDI certificate that was like burnt onto the device. But then
Hmm.
there's some additional certificates as well that like the user, so this would be like the admin, right? The network
Hmm.
admin, they'll actually be generating and creating those certificates as well. So let's get into that. How does that all work?
Okay.
Just as a quick overview, we're going to be talking about this from the network admin's perspective. So they're going to be the ones who are, say, like ordering a bunch of switches, receiving them, and then they'll need to do a few things to set up the environment to get started. So the first thing is they'll be interfacing with Massa. So you can go to massa.cisco.com. And whenever you get a new device, you'll actually add in the serial number plus a PIN domain cert. And this certificate is actually something that the admin themselves creates. So they're going to tie this serial number to a certificate that they generate to verify, like, okay, yes, I'm the person who's supposed to be onboarding this device. And then we'll get a voucher out of Massa. So for each one of our devices, we'll have our ownership voucher. And then this OV is actually something that we put onto our bootstrapping server over here. So now our environment is set up. We're all ready to go for our day zero config. So this is a brief overview of like the comparison or the side by side between our classic zero touch provisioning versus the excuse me the versus the secure zero touch provisioning. So at a high level, you can see there's a lot more back and forth that we have over here with the secure ZTP. There's a lot more validation, verification, checking certificates than over here in the classic ZTP, where we essentially find the DHCP server and then go directly to some Python file, some script to onboard, but we don't have all these additional checks and verifications over here.
I see. So there's actually a like a SSL connection, right? That's basically what's happening here is that instead of having your option 67, the Python script getting transferred over just like unencrypted, you have an SSL connection that's being established from the device to the bootstrapping server, and everything, the configuration, uh, the binary, if you update the image, right, all of that is getting transferred over that HTTPS SSL connection, right? So it's kind of in a
Mhm.
secure manner.
Exactly, exactly, yeah.
Gotcha. Okay, so you got your switches, you have your serial numbers, you went to Massa. Where is this Massa? Is that massa.cisco.com?
Yeah, yeah, massa.cisco.com is how we actually create the ownership voucher itself.
Okay.
Yeah, and we can get into details about, how exactly do you go to Massa, what do you put in there, what does it look like, as we go through today, yeah. So let's just, like, start off by breaking down all of these different components of Secure ZTP, like, what all's in here, what are they doing, and then we can go from there.
Okay.
This is just one more example of the differences between ZTP and Secure ZTP. So with the classic, we're going to point again directly to our Python file, whereas with Secure, we'll be pointing to this server where we have all of our bootstrapping data. It's like the one of the major differences that we can see in like the setup itself. So now getting into all of these different components. So of course we have our device over here. It's going to do the DHCP discovery. So it will find, okay, option 143 is configured, meaning we're ready to go with secure ZTP. So now it will go out to our bootstrapping server that now we know the location of thanks to option 143. And we'll do our TLS handshake essentially. So we'll be making a secure connection to the RESTconf bootstrapping server as well. And we'll do things over here like validating our SUDI certificate. And then we'll actually make a request to get all of our bootstrapping data. So the bootstrapping server will return us these three main components: the ownership voucher, the ownership certificate, and the conveyed information. So then we can break down all of those. What are they? How do they work? And how do they make things more secure?
And your sorry for interrupting here, story quick. Your bootstrapping server is basically just like, well, like a Linux server that you have run a HTTPS
Mhm.
server, like a web server.
Yeah, so we'll be interfacing with this using RESTconf. So it's like a REST or REST-based server over here. But yeah, it can be anything you want. It just needs to be some location where you have all of this bootstrapping data. Yeah, so all of your scripts and everything will need to be set up on here before you, plug in your device and go through this onboarding process.
Could you store all that data on like a iOS XE device?
That's a good question. I think that you can store it, wherever it makes sense. It just needs to have this REST-based operation. So if you have, say, all of your data stored on a device that has RESTconf configured, you can make
Mhm.
that secure connection. I see no problem in, using a box for that. Yeah.
Okay, because I'm asking because you're using SDHCP server
Mhm.
Catalyst for that 9,000 and I was wondering if you can use it also as a bootstrapping server at the same time, which sounds like you could. I don't see why not, because you just store on the boot flash thing for the configuration, the binaries, whatever. So, okay.
Yeah, there should be no problem with that. Usually, you would wanna have, like, separate DHCP server versus, like, a bootstrapping server, but that doesn't mean it can't be, another device, for example. That's just, one additional layer of security because if you have your DHCP server and it's pointing to, itself, then,
Mhm.
okay, all of that bootstrapping data is, like, already here. It's kind of an additional layer of security to go through the hex over here and then find, like, a different location altogether where your bootstrapping data is.
Oh,
Just
I
in
see.
case something was compromised over here, That's why we're like separating them out here.
I
Uh,
see. Okay.
yeah, yeah, but good question. I would be interested to see this use case of using a device over here. Yeah, so let's get into it. What is this bootstrapping server itself? So this is a RESTconf server, and this is where all of our bootstrapping information is included. So that's going to be all of our scripts. And this information, like, okay, so when we talk about conveyed information, you can essentially think of that as the onboarding scripts. We'll also have our ownership voucher and certificate. So we'll get into those shortly about what exactly they are and where they can be found. And then we have a guide here about Secure ZTP specifically with iOS XE. So you were asking earlier about the hex. How do you create that? How do you find, your DHCP option 143? So if you go over here to this guide, this is where we go through in detail how you can set up this whole environment for Secure ZTP and get started over here. So once we actually get all of our information from the bootstrapping server, this is essentially what's included on it. So we have our trust anchor, and the trust anchor itself is the SUDI certificate. So this is the one that's burnt into the box initially at manufacturing. So this is something that's not going to change over here. The trust anchor itself. This to validate the device's authenticity, right? Like, is it the device that we're expecting over here?
That's
And
basically a Cisco verification that is not a counterfeit device, right? It's
mhm,
been manufactured by Cisco and you've been purchasing it from Cisco, and there's no middleman, middle person type of thing, or you didn't get a counterfeit device type of thing, right?
exactly, that it's not been compromised in any way, even if it was a Cisco device and was valid to begin with, no one has been messing with it, right? The SUDI certificate is still valid over here, yeah.
Got it.
And then the last 3 here, these are all provided directly by the bootstrapping server. So we can get into them a little bit more now. Again, the conveyed information, this is gonna be our device config and any post configuration scripts. It'll be our binary file for upgrading images. All that is in the conveyed information. And then our ownership certificate. So this is used by the device to validate the signature over the conveyed information. Okay, so we're gonna sign this info, and then the ownership certificate helps us validate, okay, we're checking to make sure that nothing has been altered. Again, like you mentioned, there's no middleman over here who's manipulating the conveyed information. We're validating that it is what it was initially set to be over here. And then lastly is the ownership voucher itself. So this is how we're checking that, we are in fact the right users of this device. Like, okay, we bought it to use in our network, and we can actually see that we are the device owner as defined by the manufacturer, right? So we at Cisco keep track of who owns what devices, and how we do this is tied to the serial numbers themselves. So we can get into like a few more details of this as well. So the ownership voucher, this is when we're talking about MASA. So MASA is our manufacturer authorized signing authority. And this is essentially a screenshot over here of how we can go and actually create new requests or new vouchers. But there are two main components that we use to verify the owner of the device. The first one is the pinned domain certificate. So this is something that the admin themselves will create when we're going through and initially setting up Secure ZTP, as well as the serial number. So this is coming directly from the device itself. So we use those two inputs and we get out our ownership voucher from MASA. And here's a brief overview of what this voucher looks like. So this is a voucher file, and we can see, like when it was created, when it expires, and then we can see the pinned domain certificate is in here as well as the serial number. So again, these are the two main components that make this ownership voucher over here. So this is how we're able to validate that, yeah, we do have device ownership over here. And then we have the certificate itself. So our admin will create our ownership certificate and add it into the bootstrapping server before we even go through the onboarding process to begin with. So this allows us, we use our pin domain cert to actually like sign this ownership certificate over here. And this actually allows us to validate the signature of the conveyed information. So if you want to know how to create an ownership certificate, in this case we're using OpenSSL. And again, we have, complete details on this over in the guide on GitHub about how this works. And the last
So this is raises a couple of questions for me again. So you would have to generate the ownership certificate, right? You generate with an OpenSSL command on terminal, but
Mhm,
that is basically your enterprise certificate. So ideally, you would have a certificate authority, right? You're an enterprise that has hopefully their own domain,
mhm,
right? And you have a certificate authority, and basically you can issue certificates from your certificate authority. And that's what we're talking about here of
mhm,
generating your own certificates, right? And loading them up in Masa, associating them with the serial number of your device that gives you an ownership voucher. And that's how we make sure that, yes, this company has bought the device with this serial number from
mhm.
Cisco, and the device from Cisco is being also has a certificate from Cisco that makes sure that it's really from us. So there's a lot of components and a lot of security, sounds like, baked into this process.
Definitely, definitely. Yeah, you've exactly got it. So there are
Okay.
lots of different components and verifications, validations that we're doing, from the device side, like, is it supposed to be onboarded by this person? And also even on, like, the server side, like, how do we get to the bootstrapping server? Who's allowed to access it? That type of thing. Yeah, so there are many, many different steps along the way to make sure that, yes, you are in fact the person who should be onboarding this device, and the scripts that you're giving it are validated by the owner too. So that's kind of what we're talking about here is this owner validating the signature over this conveyed information.
Gotcha.
So
Okay.
quite a few steps over here, but essentially the goal is to make it as secure as possible. And we're following the RFC standards over here for Secure ZTP. So the last component here of the bootstrapping server is our conveyed information. Okay, we've been talking about this a lot. This is going to be all of our scripts and everything that we need for our onboarding, and this is the example that we used at the beginning. So this can be, like a Python script if we were just talking about classic ZTP, or it can be a configuration file over here in Secure ZTP, whatever we need. But essentially, these are the onboarding configs that we want to push to our device at day 0. And we were talking about image upgrades as well. So this is kind of an overview of what this can look like. Okay, so right now we're looking at essentially the Yang. We see we have a ZTP conveyed information, and we're looking at our onboarding info. And in this case, we want to update the boot image. So you can see here we're pointing to some URI where, okay, this binary file exists. So we're showing, okay, when you go through the onboarding process, of course, you're going to have your encoded scripts that you want to configure, but also you have your bootstrapping image, your boot file. Oh, I think I went offline there. Am I back?
Yeah, I don't know what happened. You're back. That was strange.
Okay, no, sorry, I'm losing connection, I guess. I'm coming in and out here, but hopefully you can hear me now.
Yeah.
Yeah, so this is just the example of onboarding an image and how we can grab an image during the secure ZTP process over here. And also in the conveyed information, we can have pre and post config as well. So in this case, I'm just doing a simple Python script where I'm grabbing like a timestamp. I'm saying like, okay, this file is created in the pre-configuration script. And similarly in the post config script as well, I'm showing a timestamp so we can see exactly how long, this onboarding process will take us. Those can be completely customized too. And then we have some examples of setting up DHCP. So this is for reference, but since you asked this question, we can get
Mhm.
into it a little bit more. Okay, so there are two main ways that you can set up DHCP option 143. So this one is like the generic DHCP address pool. So we saw the example where we were actually using hex code, and we have
Mhm.
more details on DHCP, how to get that set up. There's also, open source ways to do this for DHCP um, v4 or v6. So we can have, in this case, it's like an option ZTP redirect. So this is essentially the same thing as option 143, but in here we have, kind of more of plain text where we can actually define like the IP, and we're saying like, okay, go over here to this RESTconf server, find all of your bootstrapping data over here. So kind of two approaches. If, for example, you don't want to go the hex route or whatever, it's okay. You don't have to do that.
Yeah, basically, if you have your own DHCP server running on a Linux machine, right, that's the right-hand side, and it's an ISC DHCP open source server, then that would be your config for Secure ZTP that you
Mhm.
have to put in.
Exactly. Yeah. Yeah. And these are essentially doing the same thing here of, from DHCP, we're saying, okay, here's your bootstrapping server. We're using Secure ZTP. Go over to this location to find all your info to get started, to get going.
And you have over there actually in the server config an option as ZTP redirect code 143 equals text. I see. So then you're just pointing it under the subnet. Gotcha.
Yep, exactly. So here's where we're kind of doing the ZTP option. And now if we were using classic ZTP instead of using option 143 here or here, we'd be using option 67. And so
Hmm.
that's just telling us, okay, go here to find the Python script instead of go to this location to find all your bootstrapping data. It's a major difference here.
All right, logs.
Yeah, logs for secure ZTP. So we can actually see where we are in the process using, our Yang models over here. So in this case, we're looking at our like report progress, and we can see kind of where we are. So in this case, our, bootstrapping is complete over here, but we could see, if it was in the process too, or kind of see if we're stuck anywhere. These logs will actually help us to see more detail as to where we are in the secure ZTP process. Yeah, so we have an overview of classic ZTP, where we're going through, again, this is option 67 instead of 143, and we have tons of resources like, okay, YouTube videos, blogs, and even like some more information about how to get set up with these. Like, we have some labs as well. Okay, and then going into like our certificate generation. So, like, how do we actually get everything set up? We've talked about all these different components of Secure ZTP. We've talked about all of these different certs and vouchers that we need, but how do we set that up as the admin? So this is what we want, right? This is the ideal goal where we have our device, our DHCP server, and our RESTconf server. But we're going to talk about how to get all the information we need actually in the RESTconf server itself, how to use Massa, and all that good stuff next. So if we want to set up everything in kind of this gray box here, there are a few things we need to do as the network admin, which is, okay, we need to get all the information into the bootstrapping server itself. So that's going to include our ownership certificate and conveyed information.
Hmm.
So again, the ownership cert, something we create, the conveyed information, these will be all the scripts. And then we're also going to create a pinned domain certificate, and that's what we send over to Massa along with our our ID from the device itself, our serial number, and then that's how we get the ownership voucher. So we'll send that over to the RESTconf server as well. And again, this is just the initial setup from the admin side. This is kind of like what the full overview or workflow will look like once we have everything set up. So how do we do those things? How do we create like the pin domain certificate and the ownership certificate, for example? So, okay, again, these are like open SSL. We go into lots of details on how to do this over in the guide on GitHub. But essentially, these are things that are created by the admin and maintained by the network admin. And one thing to kind of note here is like our pinned domain certificate. This is used to sign our ownership certificate. So our pinned domain certs are rarely used unless we, have more ownership certificates that we would need to sign. So it's most secure if we store those kind of like offline. We're not going to be needing to use those all the time, right? We just need to use them initially to sign our ownership certificate. And then the ownership cert, so this is gonna be used more often, more frequently, like whenever we're onboarding devices, we're gonna be using this ownership cert. We're gonna be downloading it from the bootstrapping server and applying it. And so this one definitely needs to be rotated more often just because it's used more often. And it's gonna be actually on the bootstrapping server itself. So this is a little bit of an overview into the certs themselves, how to create them, how to maintain or manage them. And then we go into more detail of this in the guide, so we can go into this as well too. We're going to, use OpenSSL to actually create our pin domain cert, and then we go through and set all of the necessary values, and
Hmm.
then we can go ahead and sign our key over here in step 3, and then we validate that we have everything we need. Okay, we have our certificate, we have our key, and then the pin domain cert and the serial number is what we're gonna add over into Massa. So we've just created the pin domain cert. Now we need to go into Massa and actually talk about how does this work. So Massa again is this manufacturer authorized signing authority, or you can see it at massa.cisco.com. And this is our certificate verification service. So essentially, this is what it looks like if you sign into massa.cisco.com. You can see some serial numbers and then you can actually download the vouchers themselves. So we have some documentation, and this has been in XR for a while as well, but today we're talking about XE more. And you can actually work with the Massa server programmatically as well. So there's a pretty in-depth API guide for how to work with these vouchers, how to manage things within Massa too. So essentially, this is the workflow that we follow is we're going to be providing our pinned domain certificate, which we created along with the device serial number over into Massa. And then we generate our ownership voucher and put that into the bootstrapping server itself. So this is how we create the ownership voucher and actually get it into the bootstrapping server is we essentially need to go through this process for any devices that we want to onboard. And Massa has the option to actually um, create a lot of ownership vouchers at the same time. So say you have like 100 new devices, okay, you can go through this process once and add in, all the serial numbers with your pin domain cert and create ownership vouchers for all of those essentially at the same time. So you don't need to do this step every time. You only need to do it when there are new devices that are going to be onboarded. You need to put that ownership voucher associated with the serial number into the bootstrapping server itself. But then you can onboard that device using Secure ZTP as many times as you want to until, I guess, the the voucher expires, right? You can just keep doing it over and over again if for some reason you need to run the Secure ZTP process, or if you change out your scripts, for example, then you want to run Secure ZTP again to apply the new day 0 config, you can do that as often as you need to over here.
Okay, so you have an ownership voucher for every single device that you want to onboard, right? And
Yeah.
then there's a lifetime for each voucher. Do we know, like by default, how much is that lifetime?
Yeah, usually the default will be 1 year,
One
expires after,
year.
but over in Massa, you can actually define, um, how long it can, be before it expires. So, you can have it for longer than a year, or, some people only have it for, like, 30 days, for example, like, they want to rotate them more frequently. It all depends on your setup and how you wanna approach it. But yeah, let's get into it. How do we use Massa? So, we can create, like, a new request over here, And then we add in our pin domain cert that we have created, and we can add multiple different serial numbers here. So this is how we can do kind of like our bulk creation of ownership vouchers. And then to answer your question about, okay, how often are they here? The default is 1 year, but we can change this more or less. Or sorry, so it can be more frequently that we need to update this voucher. And then the default is XR, but for our case, we'll change this over to XE. And then we can go ahead and request our voucher and download them from here. So once we get these from Massa, then we'll just need to put them onto our bootstrapping server to be ready to go. So now we have all the bootstrapping data that we need to actually get going with this.
And I see you can load up also a file with the serial numbers. I would imagine, is that like a Excel file?
I'll need to check what type of file it is specifically here, but as long as it has all the list of um, like serial numbers, it should be good to go.
Okay.
Yeah, because you can also, just do comma separated values as well if you want to. You can add
Mm.
it a lot, yeah, over here. So whatever is easiest for this like bulk upload. We also have some Yang models as well that are associated with Secure ZTP. So I'll just go over these like at a high level pretty quickly, and then we can get into some resources here. So the first one is our get bootstrapping data. This is essentially the most important one because this is what we as the device are essentially going to ask of the bootstrapping server. So we want it to give us, all our onboarding information. We want our voucher, our certificate, all that good stuff. So we'll go ahead and ask for those. And then we have some optional values as well. Like if we want, signed data to be preferred, or if we don't care if it's signed, maybe we want unsigned data is fine. But essentially, this is all the data coming from the bootstrapping server. And then we have the reporting levels. So we were talking a little bit earlier about logging and how to know kind of like where we are in the process. Our reporting level is helpful when there's like information and it's not sent to like processing or redirect info, or the bootstrapping server is untrusted, is when we're like not going to send it. And then our conveyed information, okay, so we can ask specifically for just like specific info over here. This is the output of our bootstrapping data. So we're going to be getting, all of the scripts, everything that's needed to onboard our device
Mhm.
as ownership certificate itself here, and the ownership voucher, the OV. And then we have our trust anchor certificates as well. So this is the trust anchor itself, and we can actually get this out within the reporting process. Then I have just like a couple of resources here, and we can get into any questions if there may be some.
Oh,
Uh,
there's a blog too.
yeah, there's a blog about this going over essentially everything that we just chatted about, but in written form. So if you learn better that way, definitely check out this blog on Secure ZTP. And we also have this guide. So this is a more of a technical details about how you can go in and actually set up the bootstrapping server, what each of these components are and what they mean within the context of iOS XE onboarding. And then some examples too about, okay, how do you set up the hex for DHCP? How do you create the pin domain cert? We have all those details over here on GitHub. And this is again, more technical version of say like the blog, for example. And if you want ZTP, no, this is the classic, not the secure. We do have like lab and lab guides, so you can see how to go through the classic ZTP process over here. And also, I wanted to highlight open programmable infrastructure OPI as well. So this is one way that you can create your own bootstrapping server. So kind of the guidelines from Cisco are that you should create, maintain, manage your own bootstrapping server. And there are a lot of details here from OPI about how to do that and what essentially the expected inputs and outputs are at each step of the way for Secure ZTP. And of course, we have a white paper going into details of all days of the programmability and automation lifecycle here. Um, yeah, this is the overview of all the different resources I had and wanted to share out here.
Okay, because yes, that OPI server looks like it's a Docker um, image. Yeah, that was gonna be my next question. Because like, okay, you have a RESTConf server. How? Right? That was gonna be. Is it like an nginx server, and you just enable like a RESTConf interface on it, or like what is it? So now I see that actually there is a Docker image for like a bootstrapping server that you can run as a Docker
Yep.
container,
Mhm.
basically. Okay, so that provides that RESTconf interface, right, to
Yes.
the device. Okay. All right. So now it's clear in my mind. It's like, okay, RESTconf server on Linux. How do I do that?
Yeah, yeah, so one way is to use this, Docker container, and with this, like, OPI project, basically, they go through all of the examples here about, like, you can see the outputs, for example, that are expected from the conveyed information, so all of the data at all the different steps is, like, available over here, but again, this is completely customizable too, about how you want to create this bootstrapping server, what all needs to be included on it, and of course, you can add, additional security checks or validations, verifications as needed.
Okay, and then so you have this Docker image. How do you pass in your information into that Docker image, right? So your certificates, right? Your conveyed information. Do you start your Docker container, you run it, and then I would imagine you connect to it, then you drop in all this information in the specific folders?
Exactly, yeah, so you'll
Okay.
need to have it running, put everything into, the Docker container itself, and then you'll be able to get that information out of the Docker container when you're going through the Secure ZTP process, when you're onboarding your device, yeah.
Or you could also have it, I would imagine, passed as a parameter uh, into your Docker file, right? You could have it mapped on specific paths on your Linux server. So it's like, okay, get the conveyed information from this path,
Yes. Yeah.
get
Mhm.
the pin certificate from this path. You can find it, right? Um, cool. All right. So that answers that question, right? You have this Docker image already ready for you folks, RASCONF based that works with Secure ZTP. You said story best practice is to have the DHCP server and the bootstrapping server separate, also from like a security mindset. If one gets compromised, you have the other one, right? So that's also something to keep in mind. Um, Generating the certificates, you've shown us with the OpenSSL, right? If you folks haven't done that, it's pretty straightforward. OpenSSL is pretty much installed on all Linux distributions by default. You can get it also on macOS. I'm sure with WSL, you can get it running on Windows too. We've talked about Masa, right? That's new to me. I've never heard about this. It seems like it has been used with XR before, right?
Mhm.
And now it's being expanded into XE. So glad to see that. Um, you generate your vouchers. They're valid by default for 1 year. They generated for every single device. You have one of these ownership vouchers for every single device. You load it up on your bootstrapping server. You have them there in a path already predefined. Um, you can recreate them after a year, right? Is that the idea? You can like regenerate them after they expire.
Exactly, yeah. Yeah, so you can
Okay.
create new ones after they expire or, yeah, go through a similar process again. So ideally, you would have, some automation too and like how to create these vouchers. So the first time you do it, you can do say like the manual way where you're actually going in, creating a new request and filling out all this info. And then once you sort of mature and how you're working with this, you can then also use like the APIs or create some scripts to say like, okay, here's my list of all my serial numbers And here's my pin domain cert. Now go to Massa and generate me OVs for all of these.
Right. And like you showed, Massa they have an API, and you said it's fairly, uh, you can do a lot of, yeah, right here,
Mhm.
Cisco Massa server. Okay, so it's like an Swagger interface. And you can automate if you have like 5,000, like you said, or 10,000, 50,000 devices, right? You don't want to go one by one and add them manually into this. You for sure you want to automate that process. One way would be to have them in a CSV file, right? Or another way would be to just programmatically interact with Massa and upload your serial number information, download the ownership voucher, kind of in the programmatic way automatically. Um, cool. So this is really nice. So, Story, how did we decide to do this? Was like a customers were requesting this. I would imagine they were looking at ZTP as like, oh, this is not secure enough. We don't like it. Is like what drove the development of Secure ZTP on iOS XE?
Yeah, great question. So you're right. This is coming directly from customers who want to onboard their devices more securely. So we were listening to that. We were seeing, okay, there's like the RFC standards that we can follow. So that's the approach that we took. One thing to note with like Secure ZTP in particular is you can use this for onboarding your devices like we were talking about in the beginning, like in your devices in your network. You can onboard all of those as well as if you have some like security restrictions or like requirements where a lot of times we'll see that some customers have requirements where they're locked and they can't reach outside of the network. So when we're using bootstrapping servers, for example, as long as that is in the network and it has all the data that we need, so we've already gone through the process to get our ownership voucher from Massa, we put this into the bootstrapping server. Secure ZTP is really appealing to these types of customers because they don't need to go out and find, something that exists out on the internet, right? Everything is locally into your own locked network, and you can go through this process of secure ZTP and get all the information you need automatically. So this is really one of the big pulls or reasons why people are interested in using secure ZTP. In addition to, of course, it being more secure an option than the classic ZTP, which we've used before. And as we've been talking today, right, it's many steps are involved, and the purpose of that is to make it more secure, right? So that's the main benefit here is we're creating a more secure process to go in and onboard our devices and to verify that we are the owners who are supposed to be onboarding them. We have the proper scripts to onboard them, and we're doing all the proper validations here.
Gotcha. So, do you know how granular is the Massa interface? Like you create, I would imagine your Cisco customer, right? You log in with your CCO into massa.cisco.com. You already get put into your org, whatever
Mhm.
company you're a part of, right? And then it would be the admin of that enterprise, right? That kind of controls access to the CCO accounts to Massa, right? Because I mean, somebody joins the team or leaves the team that I want them to be able to manage this. It's as easy as just adding their CCO account into the Massa interface and giving them access to this, so they can actually perform all these activities. Is that's true, right?
Yeah, yeah. So we don't want people who are no longer in the group or shouldn't have access to be able to access Massa. Yeah. So exactly. We're only going to have the folks here who should have like current access, and also we can update the vouchers, as needed.
Gotcha. Um, all right. Any any other thing? Let me think. What else? We've talked about the bootstrapping server. We've talked about the HCP. We've talked about Hex, how you generate it in option 143. Um, any benefit of using ZTP anymore? Dexter, thanks for joining. I came with a question. Any benefit of using ZTP anymore, or is it essentially dead? telnet versus SSH or FTP versus TFTP type of mentality?
Yeah, great question here. So you're asking about, the ZTP classic ZTP versus the
Mhm.
secure ZTP here. So still today, a lot of people are using the classic version of ZTP over here, and the reason why is because they maybe don't have like a bootstrapping server. They aren't ready to take the next step in like securing their bootstrapping server. So it's all about priorities, right? Like we're giving you multiple options on how to onboard your devices, whether that's using a controller with plug and play, whether it's using classic ZTP or the secure version. So we'll definitely see more and more folks like adopting secure zero touch provisioning as we like move forward. I wouldn't say that the classic ZTP is dead necessarily. We still have folks who are using this and will continue to use this. But yeah, that's the trend that we'll see is moving more towards the secure option. So great question.
Yeah, I agree. And the thing is, it's all happening on-prem, like you said, Story, right? So this is all ideally behind firewalls, right? They're all private IP addresses, your bootstrapping server, your DHCP server, all of that is in a contained on-prem environment. So in my mind, right, is how comfortable you are with your infrastructure and your network, right? If you want to be extremely secure, go Secure ZTP, right? That's like it's all encrypted at that point. If you're comfortable and you think that, hey, my infrastructure is fine on-prem, I have all these firewalls, then ZTP might be enough for you. Uh, right? So it's like, how comfortable are you and what type of information you're exposing over these bootstrapping servers? But yeah, I don't think it's an existential threat yet to ZTP, but who knows? If everybody gets super security conscious, then yeah, we'll be secure ZTPing soon enough. But I expect them both to be living in parallel for a while at least. Um, all right, so secure ZTP. Thank you so much, Story. Any final resources that folks can access? So we've showed them the blog post. We've showed them that GitHub. You have one, right? GitHub.com/ what was it? Your ID and then SZTP the we/SZTP. So that's where they can find a lot of details. We've showed them there's some learning labs or content that you've showed also on GitHub that people can test ZTP,
Yep.
right?
Yeah, getting some hands on with classic ZTP over here.
Yeah, yep. And we've showed them the REST bootstrapping server, Docker image, where they can find it. All right. So, folks, if you have any questions, let us know. Comments on these videos on all the platforms that we're at. Reach out to Story. You can find her. We were just talking about Cisco Live San Diego. It's coming up. It's still a couple of months away, but time flies. So find her over there. Are you gonna have this session at Cisco Live in San Diego? Story? We're gonna show folks Secure ZTP.
So for San Diego, we're not going to talk specifically about classic ZTP, but we do have a lot of programmability topics that we'll be going over. And we do have a tectorial, so we will highlight some topics like secure ZTP in those sessions, but not a dedicated secure ZTP session this time.
Gotcha. Okay, so then, folks, this video becomes even more important because this is where you get the Secure ZTP. You're not gonna hear it as in San Diego. So make sure you reference this video as you start setting your Secure ZTP servers and infrastructure and environments. Thank you all for joining. Thank you so much, Story, for doing this session with us. And folks, remember next week, same time, I'm going to send out a reminder. We're going to have Damian Garros from Ops Mill, we're going to talk about InfraHub, which is going to be an interesting session. I'm looking forward to it. Sources of truth, all of that with InfraHub next week and Damien. So looking forward to that. In the meantime, Story, like I said, thank you so much. Thanks for folks for watching. Any parting words, Story, before we wrap up and close the stream?
Yeah, just like thanks for having us, and I'm excited for everyone who's going to be using Secure ZTP in the future. So let's stay in touch.
Yep. Thanks everyone, and good luck with Secure ZTP. It's a lot of moving parts in there.
Yep,
Take care,
definitely.
folks.
Bye.
Bye.